Today on Macaulay Math, we're talking statistics. Welcome. Intro. Okay, good day. I'm Professor Macaulay. This is Math 130, Intro to Statistics, Lesson Number 1, Introduction to Statistics. Our goals for the day. We're going to do an overview of statistical thinking. We're going to define statistics and related vocabulary. We're going to talk about population versus sample, parameter versus statistic, and descriptive statistics against inferential statistics. In algebra, we spend most of our time finding exact answers to mathematical equations and applied formulas to many real-world situations where exact answers were required. Statistics is a branch of mathematics that tries to make sense of sets of data that come from the real world. That data is usually messy and full of errors. Statistics tries to make conclusions from that messy data and attempts to determine whether or not those conclusions are genuine or result from random chance. Statistics is also definition heavy, and new concepts build on the knowledge of previous concepts. It is vitally important for you to do something to make sure that you understand the definitions and revisit definitions as you progress through the course. I suggest having a section of your notebook as a glossary or making a deck of flashcards to keep your terminology in order. Let's get started. Okay, what is statistics and statistical thinking? Now, most of you are probably coming from an Algebra 2 class of some sort, and most of the tasks in an algebra class ask you to solve an algebraic equation or manipulate a formula to come up with a solution. In statistics, you are given sets of real-world data and are asked to interpret that data using given formulas. Unfortunately, data sets collected from the real world will always contain some errors. Statistics are used to create meaning from that data even though it isn't perfect and contains errors. What do I mean by this? Here's a simple example. This is a picture of a basketball player. Now let's say we measure his height and we measure the distance from either end of his outstretched fingertips. Now if we do the same thing to 100 people of the same height, you wouldn't expect all of those people to have the same measurement from fingertip to fingertip as the guy on the screen. But if we measured the height of 100 random people, then measured the distance between their outstretched fingertips, we would even expect that the taller the person is, the larger the distance between their outstretched fingertips would be, even if not every person that measured 6 feet tall had the same length from fingertip to fingertip. This is the kind of thing that statistics tries to make sense of. Additionally, in Algebra 2, students are asked to calculate solutions. Answers often sound like it would take 5.32 seconds for the rock to hit the ground. In statistics, solutions often include qualifiers which take into consideration the errors that exist in nature. For example, a statistics solution may sound like this. I am 95% confident that the average weight for all male high school students is 180 pounds with a margin of error of plus or minus 15 pounds. First example. We're going to answer all of these statements with three things. Either A, it's impossible, B, possible but very unlikely, or C, possible and likely. The first situation, on the way to work yesterday, I arrived at 3 traffic lights and they were all red. Now, how am I going to answer that? Well, one, I am going to say that this is both possible and it is likely. Now, why do I say that? Well, there are only 3 traffic lights, and each of those 3 traffic lights only have 3 outcomes: green, yellow, and red. So at each traffic light, there is a 1/3 chance that I get red. And I am sure that all of you drivers who have been late and have to go through 3 lights, they're all red every time you're in a hurry. All right. Now, let's talk about number 2. Number 2, everyone in a given classroom has the same birth date. Now, this seems similar to our first example, but let's see the difference. All right. When I talk about 3 traffic lights, I only have 3 events encountering a traffic light 3 times. Each of those traffic lights only have 3 outcomes: red, green, or yellow. Now, if I talk about everyone in this classroom and their birth date, in many classes, you may see 20 to 30 people. That is a lot more instances than just 3 traffic lights. Birth date is one of 365 days in a year. That is a lot more outcomes than red, yellow, or green. And so, even though it might be possible that all 30 people have the same birth date, it is very unlikely. Statement 3. Mother's Day will be on a Monday next year. Now, Mother's Day is based on a definition. Mother's Day is always on a Sunday in May. Therefore, it can't be on Monday. Therefore, it is impossible. Number 4, Thanksgiving will fall on a Thursday next year. Again, definitionally, Thanksgiving is always the 3rd Thursday in November. So this is both possible and likely. And finally, I bought a new car last week and I found a $100 bill in the trunk. It is very unlikely that a car dealer would leave a $100 bill in a used car. So I would say, even though that is possible, it is very unlikely. Statistical significance versus practical significance. Statistical significance means that we can prove that an outcome is either statistically likely or statistically unlikely, or unable to distinguish it from chance. Practical significance implies that a result is useful, and usually they say that this is in the realm of common sense. So let's talk about an example of what I mean for that. Here's my example. A study of a weight loss program in a particular method was performed. Either the method works or it does not work. 40 subjects that used the method lost an average of 3.3 pounds over a 12-month period. Statistical analysis can be used to show that if the method does not work, then there is only a 3% chance that these 40 people would lose an average of 3.3 pounds. So basically, what this says, it says if the method doesn't work, then there's a 3% chance that these people would lose an average of 3.3 pounds. Okay? That means that there is, and there's some nuance to this about negation, but it says that there is only a 3% chance that this weight loss is attributable to something else other than the method used. Well, there's only a 3% chance that something else caused it. Well, does this have practical significance? Yes, it does have statistical significance. Only a 3% chance that it's something else. That means that, and again, nuance, there's some 97% chance that it was this system that caused a 3 pounds lost. That is pretty statistically significant. And you'll see that in general, anything close to that 5% will be statistically significant. Do these results have practical significance? Well, let's talk about what happened in this program. In 12 months, I lost 3 pounds. I'm going to tell you right now, from my own personal experience as a big guy who's always trying to lose weight, if it took 3 months to lose 3 pounds, I'd have quit after the second month. 3 pounds is not enough for me to do any type of program for a year. I'm going to need to see more results than that. So, my answer to this, does it have practical significance? No, it didn't really do anything in the context of the problem. All right, moving on. Example. A study compared a surgery with splinting for subjects of carpal tunnel syndrome. The surgery is either better than using splints, or there is no difference between surgery and splints for treating carpal tunnel syndrome. Study results: among 73 patients treated with surgery, there was a 92% success rate, and among 83 patients treated with splints, there was a 72% success rate. Statistical analysis can be used to show that if there's not really a difference between surgery and splinting, then there is about a 1 out of 1,000 chance of getting these study results. Okay, do these results have statistical significance? The answer to that is, again, yes. We found that there's only a 1 out of 1,000 chance that there is a difference between surgery and splinting. That is very small. That is a very small chance that there's something different. Does it have practical significance? The answer to that is also yes. But which method you choose is definitely going to depend. Clearly, surgery has a higher success rate. This success rate of 92 is much higher than 72. But you have to decide as a person what means more to you. Does it mean more to only do one thing and get the success right away? Or are you concerned about having a surgery where you might have to be put under and actually have things cut? An actual surgery means that they're going to cut tendons, reconnect things, whereas a splint may not be as invasive. You just wrap something around your wrist every day. So even though the results have practical significance, there's still some discussion to be made upon which method you choose. Moving on. Before I start this slide, I have a quick statement about vocabulary and definitions. In statistics, your vocabulary is very important. Many of the concepts that we will be learning this semester are built on definitions and vocabulary given at the beginning of the semester. I cannot stress to you enough to take time to learn your vocabulary. For example, at the end of the semester, I am going to use the term the mean of the sample means. And if you don't know what those three words mean, and again, mean of the sample means and mean, all three of those things have different definitions. It's the same word. So you have to understand them, or you are going to struggle when we get to the end. Make some flashcards. Make a separate space in your notebook. Keep a running tally of your definitions. You will thank yourself later if you set something up now to keep track of your definitions that you can look back on later. All right, definitions for this lesson. First, data. Information coming from observation, counts, measurements, or responses. Statistics, the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. Population. A population is a collection of all outcomes, responses, measurements, or counts that are of interest. And a sample is a subset or part of a population. Definitions continued. A parameter is a numerical description of a population characteristic. A statistic is a numerical description of a sample characteristic. Descriptive statistics, the branch of statistics that involves the organization, summarization, and display of data. Inferential statistics, the branch of statistics that involves using a sample to draw conclusions about a population. A basic tool in the study of inferential statistics is probability. And again, inferential, remember, first couple of letters here is infer. It's things that you can infer about the entire population based on a sample when taking all of the data from a sample is either too big or unwieldy. Okay, some examples. In a recent survey, 614 small business owners in the U.S. were asked if they thought their social media presence was valuable. 258 of the 614 respondents said yes. Identify the population. All right, the population is going to be the responses of all small businesses in the United States. The sample is the of the responses of the 614 small businesses in the survey. And describe the sample set. The sample set contains the 258 owners that responded yes. And if I go 258 from 614, I get 356 that said no. All right, next example. Which of the following represents a parameter and which a statistic? Last year, 90% of the students in Mr. McCully's class showed a year's worth of growth on a math test, and in a random sample of 400 Coshocton County students, 67% showed a year's worth of growth on their STAR math test. Okay, so let's see here. This thing here is a parameter. And it is a parameter because all students in Mr. McCully's is the population. And this is a statistic because the population is all Coshocton County students with a sample of 400 students. All right. Example. In a study of 800 10th grade students who both took AP Calculus and did not take AP Calculus, for the students who took AP Calculus, 89% graduated college. Of the students who did not take AP Calculus, 58% graduated college. What part of the study represents descriptive statistics? The study included 800 students of the students that took AP Calc 89% graduated college, and of those who did not take calc, only 58% graduated college. What conclusions might be used using inferential statistics? And I'm underlining, highlighting, and bolding and italicizing might, because for you to say this, there's got to be some other work done, and that's what we'll be learning in this semester. But you might say that if a student takes AP Calc in high school, they are more likely to graduate college. All right. That is all I have for today, folks. So, as you know, I am kind of a nerd, so I include some Marvel fun facts of the day. Here is the first one. The Marvel Cinematic Universe is well planned out and very much connected. In this picture from Iron Man 2 from 2010, I know that's forever ago, you can see a reference to Wakanda. It's this little circle right here. Black Panther's home country being foreshadowed, even though it would be 8 years before his first movie would be released and before he showed up in Civil War, which was Captain America 2, I think, maybe 3. Well, that's all I got for today, folks. You have a great day. Goodbye.